Alright, now for the given vectors r, x, d, sc, y, and fc that I have mentioned in this slide, how would you compute their profit? Look at the pink boxes where I have provided the details of the calculation. So what is the profit in general? It is the total revenue minus total cost, which is fixed cost plus salvage costs. Let's start with the total fixed cost. What do I need to have to compute the total fixed costs? I know the fixed cost for each product, but I also need to know what product types have been produced at all. That's where the y variable makes the life easier for us. If an element in y is 1, that means the product corresponding to the index of that element has been produced, and you have to consider its fixed cost. You could also do this by looking at x, but using y is simpler. How? All you need to do is to multiply the vector y by the vector fc element by element, and then taken the sum of the elements of the resulting vector. In this example, the total fixed cost is 1 times 40 plus 1 times 75 plus 0 times 90, which implies it is $150. You could also use x to compute this cost. It would be a little bit more challenging, because in computing the total fixed cost, the number of production does not matter at all. All that matters is whether a product has been produced at all or not. That's why y is more useful for this purpose. Now let's talk about the total revenue. Can I simply multiply the vector x by the vector r? No. Why? Because I do not know if I have sold all the products that I have produced. I have to be careful here because, for example, producing 40 products does not mean that they all lead to revenue. According to the second element in the vector d, which is the demand vector, only 30 of this product will be sold and 10 of them will remain. So the revenue of this product is not the multiplication of 40, which is the total production of product 2 by 7, which is the unit revenue of the product 2. It is 30 times 7, which is 210. What is the revenue out of the product 1? Well, because the demand is 25 for this product, I will sell all the 20 produced items. So the revenue out of this product is 20 times 5, which is 100. Clearly, I do not make any revenue out of product 3 because I have no production here. So the actual revenue is 310. Now, how do you write this mathematically? Remember that as a human being, we simply compared the elements of x and d to decide how many products have been really sold. For MATLAB, we have to come up with a mathematical expression that correctly computes this value. It is easy to do that. Note that if you produce more than the demand, then the value of the demand is the number of products that you would sell. If you produce less than the demand, then the number of production is the number of products that you will sell. So you can see that the number of sold products for each product is really the minimum of its demand and its production. So I have a neat formula to compute the total revenue. I can first compute a vector in which the elements are the minimum of respective elements in the vectors x and d. Then I can multiply these new vectors by the vector r. Finally, how do I compute the salvage cost? Let's look at an example. So I have produced 20 of a product 1, but the demand is 25 for that product. So that means I have sold all the items that I have produced. Do I need to pay anything for the salvage cost? Of course not. Now about product 2. The story is different here. By comparing the second elements of the vector x and d, I can see that I have 10 unsold items, so here I have to pay some salvage cost. It is actually 10 times 3, which is $30. Regarding product 3, I'm not worried. I have produced nothing, so I pay no salvage cost here, so the total salvage cost is $30. Now, what is the correct mathematical expression for the computation that we just did? The key is if we subtract the actual demand from the total production for each product and the result of this subtraction is positive, then clearly we have salvage costs for that product. If that subtraction results in a negative number, that means the production has been less than the actual demand. So for the negative values of the subtraction, we do not pay any salvage costs, so we need a function that subtracts the demand from the actual production, and if the result becomes negative, it should become 0. Okay. Basically, there is a function in MATLAB which is called subplus, which computes the positive remaining of a subtraction operation. If the result of a subtraction is positive, subplus returns the result of the subtraction, otherwise it returns 0, and that's what we need.